Hello everyone, welcome to Maths with Mr. J, and today I'm going to show you how to solve this problem. Find all the possible value of r. Solution: 9 raised to the power of r minus 3 raised to the power of r equal to 6. First step, we express 9 in base 3. If we express 9 in base 3, we have 3 raised to the power of 2 all raised to the power of r minus 3 raised to the power of r equal to 6. Next step, we can interchange the power. Since we have a times b is equals to b times a, which is the commutative properties of multiplication. If that is true, we have 3 raised to the power of r all raised to the power of 2 minus 3 raised to the power of r equal to 6. We continue, we say let 3 raised to the power of r equal to p. Then this expression will change to p squared minus p equal to 6. Then let's take 6 to the left hand side of equal to sign. It becomes p squared minus p minus 6 equal to 0. This becomes quadratic equation. Now we have quadratic equation. We have different methods to solve quadratic equation. We have factorization method. We have using quadratic equation formula. We have completing the square method. We have graphical method. But in this question, I'm going to use two methods: factorization method and quadratic equation formula. Now let's start with factorization method. What we do, we write p squared minus p minus 6 equal to 0. Now let's look for two numbers. When we multiply it, it will give us minus 6p. And that same number, when we add it, it will give us minus p. So we write minus 6p squared. We look for a number that we will multiply to give us minus 6p squared. And that same number, when we add it, it will give us minus p. These numbers are minus 3p times 2p will give us minus 6p, and minus 3p plus 2p will give us minus p. Now we continue. This will be p squared. In place of minus p, we replace it with the two items, which is minus 3p plus 2p minus 6 equal to 0. When we add minus p plus 2p, we get back minus p. Then nothing changed. What we do, we group them into two brackets. We have p squared minus 3p in brackets plus 2p minus 6 in brackets equal to 0. Then we move further. We look for what is common. What is common is p into p minus 3 plus what is common in this bracket is 2 into p minus 3 equal to 0. If you look at the brackets, they are the same. We pick one of the brackets and pick what is outside the bracket, meaning our answer becomes p plus 2 in brackets into p minus 3 in brackets equal to 0. What will make this expression 0? Either one of the brackets will be 0. We say either p plus 2 equals 0 or p minus 3 equals 0. That is, p equal to, when 2 crosses sign of equality, becomes minus 2, or p, when minus 3 crosses sign of equality, it becomes 3. Therefore, p is equal to minus 2, 3 as the answer. Now, I told you I'm going to use two formulas to solve this quadratic equation. Now I'm going to use quadratic equation formula to see if we get the same answer as p equals to minus 2, 3. Now we have p squared minus p minus 6 equal to 0. Using quadratic equation formula, we have p equal to minus b plus or minus square root of b squared minus 4ac all over 2a, where a is the coefficient of p squared. Coefficient of p squared here is 1. B is equal to the coefficient of p, which is minus 1. And c is the constant, which is minus 6. We continue. When we substitute the value of a, b, and c into the quadratic equation formula, we have p equal to minus into minus 1 plus or minus square root of minus 1, which is b squared, minus 4a, which is 1, times c, which is minus 6, all over 2a. A is 1. Then p will be equal to minus times minus gives us plus 1 plus or minus square root of minus 1 square gives us 1 plus minus 4 times 1 times minus 6 gives us 24 all over 2a gives us 2. P is equal to 1 plus or minus square root of 25 all over 2. P is equals to 1 plus or minus square root of 25 is 5 all over 2. Then P is equal to 1 plus 5 all over 2, or 1 minus 5 all over 2. If we continue, P is equals to 1 plus 5 gives us 6 over 2, or 1 minus 5 gives us minus 4 over 2. P is equals to 6 divided by 2 gives us 3, or minus 4 divided by 2 gives us minus 2. Therefore, P is equals to 3, minus 2. As the first answer we have here, which is the same, but that is not the end. We say let 3 raised to the power of r equals to p. Now we are going to put p in place of 2 and minus 2 to look for the value of r. Then we continue by saying recall 3 raised to the power of r equal to p. Case 1, let p equal to 3. Now we have 3 raised to the power of r equal to p. Wherever we see p, we put 3, and this 3 is raised to the power of 1. We compare the base. Base 3 will cancel base 3, left with r equal to 1. Then case 2 is when p is equal to minus 2. We can reject this case because the value of 3 raised to the power of r must be greater than 0. But if we continue, it will give us complex answer. Let's just continue and stop on the way. 3 raised to the power of r equal to minus 2. What we do, 2 of the numbers are not in the same base, and there is no way we can express it in the same base. What we do, we introduce logarithm. When we introduce logarithm, we have log of 3 raised to the power of r equal to log of minus 2. Then in law of logarithm, we have power log, where we have log of n raised to the power of x can be expressed as x log n, meaning x will just come down and multiply the log. If this is true, the left hand side will be r log 3 equal to log minus 2. To get r, we divide both sides by the coefficient of r, which is log of 3. That is r log of 3 all over log of 3 equals log of minus 2 all over log of 3. Log 3 we cancel log 3, left with r, equal to log of minus 2 all over log of 3 is a normal base. To change it to base 3, we have log of minus 2 in base 3. To express this expression, we will stop here because it will be a complex number. So the final answers are r equal to 1, comma, log of minus 2 in base 3 as the answer. Now we want to check if our answer is correct. Then we write down the original equation, which is 9 raised to the power of r minus 3 raised to the power of r equal to 6. Put r equal to 1. If we put r equal to 1, we have 9 raised to the power of 1 minus 3 raised to the power of 1 equal to 6. 9 raised to the power of 1 is 9, minus 3 raised to the power of 1 is 3. Will it give us 6? Yes. 9 minus 3 is 6, equal to 6. The left-hand side is equal to the right-hand side. So our answer is correct. If this helped, please subscribe, like, and share. Thank you very much. See you in my next video. Thank you.